make that turn. So if I flick it, hi guys, I'm excited to tell you about all of the hardware projects I've been working on lately. What I've got in front of me, apologies for the messy desk, but I have got about a year's worth of projects that I want to talk about. But today, I just want to talk about a career day presentation that I did recently at my son's school. We showed off a couple of these robots, and the kids were really excited. What I wanted to show was two things. I wanted to see if the kids could work together to make a hexapod like this walk, and I wanted to see if the kids could get this robot car right here to drive across their carpet, writing one line of code for each kid. So we actually sat down with the kids with my laptop, and we had them write one line of code each of C++ to drive this car straight, back, left, and right. So I want to dig into each of these projects. Let's get started. All right, so I want to show you this robot car because it's a pretty cool build kit that I did with my son. I think we did this 2 years ago, but we've slowly modified it and added on to it. And this is what we took to Career Day 2 years in a row now to play with the kids. So I just want to go over what this is and like how it works and some of the different components of it, and then I'll kind of talk about what we did at Career Day. So this whole thing came as a kit with the exception of a couple mods that I'll tell you about. It came with all these parts. So at its core, it's an Arduino Uno R3. It's actually a pretty old one at this point. That's at the base down here at the bottom of the stack. And then on top of that, this company that makes this kit is called Key Studio. I did not build this from scratch myself. This is our first foray into some robots. I would love to and plan to actually. But it comes with these acrylic plates. It comes with these two motors. On top of the Arduino R3 is their custom, it's a L298P motor driver, and it's as a shield, so it kind of pops right onto the Uno R3. And then another shield on top of that called their sensor shield. And there was a lot of open ports on here, so we were able to use that to actually add our own sound system. So if I turn it on, you'll actually hear the robot say hello. And so we've got a speaker on this side that we've added, and we've got a DF player mini here with an SD card, and you can just see how we sort of did minimal wiring to wire this up to the board, and we were able to connect it right to the sensor board here to give him some sound. It comes with this ultrasonic distance sensor, so he can see how far away he is from objects. I have it programmed right now that if I get my hand in front of his face, he'll shake it, and the kids really enjoyed him shaking his head no to various things. And then we've got this LED matrix in the front here, and you can just go to a website that can give you a data array for the matrix, so I just have a smiley face here. Then in the front, we also have a infrared receiver, which gets really fun. I'll show you about that in a minute. And then on the left and right, we actually have light sensors. And so I guess the idea is that you could sense, like if you shine a flashlight on either direction, then you could make him turn left or right. We didn't really use that, and that wasn't super exciting. So we didn't do too much with that. And then as you saw, the head moves, so it's on a servo. And then I think the only other feature is really just around back. We just have the 18650 batteries that are charging this thing. When I first built it, we actually got a little bit of smoke because we crossed the wires on the battery, and that was no good. So it didn't break anything, luckily, and we were able to put it back together. And my son is 6, and he was able to put this together a year ago. So it was a great little kit. The way it comes with this remote, and what we were able to do was program to do a few different pieces of functionality. So what I have it is just if I use the arrow keys on here for the IR receiver, he'll drive. Probably shouldn't do this on the desk. And I was able to explain to the kids how like left and right would work in this situation with two motors. And I was able to say like, hey, like this one is going to spin and this one isn't if I go that direction. And so you can see this is spinning and this isn't, or just a little bit. So it can actually sort of make that turn. Oh my gosh. See, this is why a messy desk is a bad idea to demo something, but you just gotta record, right? What we did with the car is I actually opened my laptop and opened up the Arduino IDE, and I had the kids write one line of C++ each. And I wrote some functions ahead of time that was like turn left, turn right, go forward, go backwards. And so the kids didn't have to worry about implementation. They just had to write those lines of code. And so what we did is we had a big carpet that we laid out, or that was already out in the classroom, and then I just laid out this beautiful finish paper. And then every time we would do a few kids at a time, so people weren't getting bored. So I had them type in a few lines of code, what they thought the robot needed to do, and then we would put down this stop sign that I 3D printed, and then the next group of kids would get to write sort of from there and try to get to the finish line. And we did this in a bunch of groups of kids, and we would start from the beginning each time. And when we hit OK on the remote, it executes that whole program. So if I do that right now, it's going to execute whatever program we wrote sort of with the last group of kids. So if I hit OK on here, now he's going to start going. That's the left turn, right, straight, back, straight, left turn. I guess that would be a right turn, actually, etc. And so this would just go through all of the steps for the kids, and they just got this really great feedback loop of writing lines of code, and then I physically plugged it into the laptop and uploaded the code to the robot and ran the robot. So it was really cool for them to see, like, these lines of code, these words that I'm typing are resulting in the robot actually moving across the carpet in this exact way to accomplish a goal to get to the finish line. Now, 2 years in a row I've done this, and 2 years in a row no class has actually gotten to the finish line, mostly because they don't work together properly. They don't think about, well, some kids do. Some kids are like, no, we need to go straight, we need to go left, and they're all kind of rooting, and the other kids are like, oh, go left. And so every kid is kind of understanding at a different pace. And so it's cool to see some of the kids that are clicking with it. I think that a couple more years, and or as my son grows older and I do it for the older grades, one of these grades will get it. So maybe it'll be second grade, maybe it'll be third grade, but one of the grades will get the car to the finish line. They'll all work together. Okay. Now the other thing that I wanted to do with the kids was show how this infrared thing works, because it's actually like a really cool concept. I gave the kids a flashlight, and I said, hey, how would you communicate with a flashlight? And they were like, they intuitively understood, like, oh, 1 for yes, 2 for no. Infrared works not exactly like that, but still with shining light. And so just the way this works is the same way. Well, there you go. If you shake this magic wand and point it at the sensor, I have the code read the ID of this wand, and when it detects this, and only this particular ID, it'll play that sound. So if I flick it, you'll get my son saying funny things. And he was really surprised when I brought this wand into the classroom. He had no idea what I was doing with his wand, and he told me, don't hurt the wand. And I told him, trust me, it'll be fine. But all the kids knew this is from like an indoor water park that has this magical sort of like game you can play as you walk around the water park, like the inside area of the water park. And so the kids knew about all these because it's sort of from our area, and so they were really surprised. And I explained to the kids, I was like, okay, like this shines light, and I explained what infrared is, and I said it's 65,000 times per second, and then there's a gap, and then 65,000 times per second, and then another gap, and then we measure those gaps, or at least this is measuring the gaps. And if it's this amount, it's a 0. If it's this amount, it's a 1. And I didn't tell this part to the kids, but it's a 30 for you guys. It's 32 bits. You can send enough data that way. It's actually wrapped in an envelope, and what that means is it sends like 9 microseconds of the 65,000 hertz frequency, and then after that it sends the data, and then it reverses the data as a checksum, and then it sort of closes the envelope. And that's how this works, and that's how we were able to code what this was. That the buffer was too short, then I was able to get the full data, and now I reliably am able to flick the wand to get it to speak. Maybe I need a little more debouncing in here. I'm going to turn this off so that doesn't keep happening. There we go. And I think, I think playing with these kind of things, these infrared lights, these sensors and things, the kids just really love seeing this stuff open with these wires and everything. So I think this one was really impactful. But let's move on to the next one. This is also a pretty big hit, and the kids really enjoyed this one. This is another kit that I got, and I have over here an open one to show you. So it's just running an ESP32 in the middle here, and it's a newer one because it's got a USB-C port, and it's got their own custom daughter board underneath. It's just a it's just an 18 servo hexapod, and it's pretty neatly wired, and it's got a ultrasonic distance sensor that actually has lights built into it. We'll look at that in just a second. But I have this one closed up over here for use in the demo. We put together a lot of different boards for this. I actually have 2 of these, and what we're looking at is it's just a breadboard with an ESP32 on it, and I have these 6 joysticks out here. Well, 3, and I've got another one of these also. And together, the kids would make this hexapod walk by controlling 3 at a time. And the way we do that, and actually, let me give you a demonstration of this. So I've 3D printed these housings for these joysticks. So let's actually take one of these out for a second. I don't have enough joysticks to have all of this, so we'll take out these wires, take this joystick out, just a standard one. And I have this remote, this single remote, another ESP32 here, and this single remote, I'm just going to put this in. So these are the ground wires right there, so that's going to pop in right there. Okay. Now, to power this, I've got a way too big of a battery, but whatever. So we've got a 3.7 volt battery, and we've got a boost converter to 5 volts so that we can send it to the ESP32. So I'll just plug this into the ground rail right here, and then we'll send the 5 volts to the V-in right there. Okay, and that would have worked if this wire didn't immediately come out. So let's fire up the soldering iron and fix that. There we go. Soldering iron is on. While we wait, I'm going to use a backup that I have. New battery, 3000 milliamps, and we're going to get some ground right there, and we'll get some V in here. Now, I did this in front of the kids because I wanted them to see what it was like to kind of have these raw electronics here and do stuff. And so how this works is I'm actually going to turn this spider on so he gets kind of uppity, which is kind of fun. And then using this controller, I can make him walk forward and back. Let me actually move this over here. So let's have him walk a little bit. There you go, forward, back, left, and right. And the way this works, if I move him forward, if you can kind of see, they're actually moving in a tripod formation. And so you've got this leg, and this leg moving it together, and then the other 3 moving together. And so that's why we did 6 for the kids. So this was just to demonstrate, and you can do some fun stuff, like he can do some poses, and he can wave, and he's got some other poses as well. I don't have those programmed onto this remote here. When this kit was here, the only way to use this kit was to use Bluetooth over the phone, and I don't want my kids using my phone all the time, so I didn't want that. So I was like, I'm going to make my own remote. That's this guy. And the way it works is over ESP Now. And if you're not familiar, ESP Now is a super easy protocol. It uses a local Wi-Fi between the ESP32s, and I can just send signals as if they're wired together. It's actually that simple. And it works so well, you can actually do this with multiple. So that we actually had, you can have 2 of these other 6 here, powered these the same exact way, ESP32, and instead of just these 3, I have a second one, and then you can have the kids all control one at a time. They can individually control the legs, or they can work together 3 at a time, like the tripod motion, and actually have them make this guy walk. And so that's what we had. We had 6 kids at a time, all rooting each other on, all trying to work together to make this spider, not really spider, but make him walk. And it was a lot of fun getting them to do that, and it was a lot of fun showing them these sort of raw electronics. They had so many questions about seeing electronics wired up this way, because it's just so different to a toy that has a case on it. And so seeing just the wires and the buttons and everything. It was really cool to see them do that. So okay, our soldering iron is hot, so we can fix the other one. Heat up the pad. And get you back on there. There we go. Nice and solid. Give you some ground like you did before. And give you some V in. And there you go. We're powered again. We can test them out. Give you a wave. Oh, give you a wave. There we go. All working great. Yeah, I think the car with this Hexapod and seeing these electronics was really cool for the kids. They got to play with it hands-on. So anyway, just a cool project. I just wanted to share that with everybody. Thank you so much for watching.